Here the diagrams somewhat are not clear because of drawing. Now I show you in this book, the book version of this diagram. Uh, this is the AAA type, means in two-dimensional the particles are placed one over another in the same manner. So this is AA type, and here the second row is placed between the space at the space between the two constituent particles. तो दो particles के बीच में space है उसमें place किया हुआ है. तो this is called AB structure. So here the coordination number is 4 because one particle is in contact with the 4 particles surrounding the central particle. 1, 2, 3, 4. So the coordination number here is 4. And here the coordination number is 6 because the central particle, one constituent atom is surrounded by is in contact with the 6 surrounding atoms. Here the coordination number is 6. Now I think that the concept is clear, and now we come on to the close packing in 3-dimensional. In 3-dimensional, close packing in 3 dimension, because all the real structures, they are 3-dimensional. Then what happens if we look at the 3-dimensional close packing? Then we have to place another layer of particles over this layer. So second square close packed layer above the first, we follow the same rule that was followed when one row was placed adjacent to the other. Suppose this is layer A, and above this layer we place the second layer on and above these, aligning with these constituent particles. Then what will happen? We will get AA type structure. This is A layer, and we place the second layer on the layer A as the particles aligning with these particles in A layer. So that will also be A type structure. So we get AA type structure, AAA type structure. The lattice which is generated is simple cubic lattice, and its unit cell is the primitive cubic unit cell. Now if we place this second layer over the first layer, 2-dimensional hexagonal close packed layer A, and place a similar layer above it in such a manner that the spheres of the second layer are placed in the depressions of the first layer, then what will happen? Since the spheres of the two layers are aligned differently, we say that second layer is B because they are aligned separately. The B layer particles are placed in between the depressions. जहाँ खाली जगह है वहाँ पे B के particles आ गए हैं. इससे जो लेयर है वो डिफरेंट स्ट्रक्चर से B टाइप स्ट्रक्चर is placed over the A-type structure. And now the third layer, let me have a different paper to explain it. Close packed structure in three dimension. Now A type structure, and if the second layer is placed above it, that is also aligning with these, then we say that it is A type structure. But if second layer is such that the particles are not aligning with the A layer, but the particles are placed in the depressions, in the vacant space, here comes the particle, here comes the particle of second layer, then what happens? The second layer B is created, and if the third layer C is aligned with the A, if the third layer particles is aligned with the first layer A layer particles, then we say that it is AB structure. And if what happens, even the particle of third layer are not aligned with the first layer, then it will be third layer will be C layer, and the structure will be ABC structure. Here when there are two types of voids, vacant space or voids or vacant space. Two types of vacant space. One is octahedral and the other is tetrahedral. When the third layer is aligned, AB type structure, the third layer is placed on octahedral voids, and when the fourth layer is aligned with the first layer, that is ABC structure, then the fourth layer particles are placed on tetrahedral voids or tetrahedral vacant space.